Hello everyone, welcome to Edupedia World Videos. In today's lecture, we will discuss Octet Rule and properties of ionic compounds. What is Octet Rule? The Octet Rule states that atoms tend to gain, lose or share electrons so that their outermost shell holds 8 electrons as in the noble gases. The Octet Rule is a general rule and we can explain the formation of most ionic and covalent compounds with the help of Octet Rule. An atom of potassium has a tendency to lose one electron so as to acquire the electronic configuration of argon having a stable octet. But an atom of chlorine needs one electron to attain the stable electronic configuration of argon. So, one atom of potassium must combine with one atom of chlorine to form potassium chloride or KCl. After losing an electron, the potassium atom acquires a unit positive charge because its nucleus has 19 electrons and there are 18 electrons in its K, L and M shell. So a potassium cation is formed. And after accepting the electron from potassium atom, the chlorine atom acquires a unit negative charge because its nucleus has 17 protons and there are total 18 electrons in its K, L and M shell. So a chloride anion is formed. We can see the chemical reaction which occurs. Potassium, chemical formula is K, electronic configuration is 2, 8, 8 and 1. So it will lose one electron to acquire a stable noble gas configuration. Now its configuration is 2, 8 and 8. For chlorine, it will accept one electron. Its electronic configuration is 287, Cl negative, chloride anion will be formed and its electronic configuration will be 288. So potassium and chloride ions are oppositely charged. There exists a strong electrostatic force of attraction between them, and potassium chloride exists as aggregates of oppositely charged ions and not as molecules. So there is one electron in its outermost shell and there are 7 electrons in its outermost shell. K will become K positive. It will give its one electron to chlorine and chloride ion will be formed. Its electronic configuration will be 288 and the electronic configuration of Cl will also be 288. So in this way potassium chloride will be formed. So examples of ionic compounds are chlorides, fluorides, nitrates, oxides and sulfides of sodium and potassium. And chlorides, fluorides, nitrates and oxides of magnesium and calcium. These are examples of ionic compounds. Now we will discuss properties of ionic compounds. The first property is physical nature. The ionic compounds are solids. They are hard due to the presence of strong electrostatic forces of attraction between the oppositely charged ions. They are brittle and their crystal break into pieces on applying pressure. The second property is melting and boiling points. The ionic compounds exhibit high melting and boiling points, since a large amount of energy is needed to break the strong inter-ionic electrostatic forces of attraction. The third property is solubility. The ionic compounds are highly soluble in polar solvents such as water and insoluble in non-polar solvents such as benzene, hexane, chloroform, carbon tetrachloride, petrol, kerosene, etc. The fourth property is electrical conductivity. The ionic compounds conduct electricity in aqueous solution and in molten state. In the molten state, the heat energy breaks the inter-ionic electrostatic forces of attraction, and as a result, the ions are able to move freely and they conduct electricity. The fifth property is aggregates. The ionic compounds do not exist as discrete molecules in the crystal lattice, but exist as aggregates of a very large number of oppositely charged ions. So these are all the properties of ionic compounds. Thank you for watching Edupedia World Videos.